Alright guys, welcome back. We are now going to do section 1.5, which is on parallel lines and perpendicular lines. So this is going to kind of piggyback on last night's lesson, and I'm going to try to keep it shorter than normal because I want to give you a chance to practice a few of those difference quotients tonight. Alright, so let's talk about parallel lines. So we know parallel lines are two lines that line a plane that don't intersect. But I really want to focus on their slopes. And what do you know about parallel line slopes? You learned this in Algebra 1 and reviewed it again in geometry. So hopefully you know that parallel lines have the same slope, which makes sense when you think of parallel lines. If slope gives me the steepness and the direction, they both have to be the same direction, the same steepness to be parallel. Okay, so if I tell you have line 1 parallel to line 2, and I'm going to give you the slope of line 1, I'm going to ask you to give me the slope of line 2, knowing they're parallel. Alrighty? So I'm going to give you, let's say that's 3, 1/2, -4/7, and 0. So again, if they are parallel lines, they would have the same slope. So this is going to be really tough, so hold on. You ready? Line 2 would be 3. Line 2, if his slope is 1/2, the parallel line is 1/2. Yes, it's that easy. If it's -4/7, the parallel line is -4/7. If it's 0, the parallel line is 0. Okay? Easy. Let's shift over to perpendicular. So let's talk about what a perpendicular line is. Perpendicular lines are two lines that intersect at a right angle. So they're going to look something like that. Okay? Now, there's something special about their slopes as well. But they're not the same. Obviously not. They're going in two different directions. They are what we call negative reciprocal slope. Okay, so again, let's say that we've got line 3 perpendicular to line 4. I'm going to give you the slopes of line 3. We're going to make them the same as they were in the other example. 3, 1/2, -4/7, and 0. Alright, and let's talk about line 4. Who is perpendicular. So, negative reciprocals. First thing, change the sign. That's what it means to negate or to be negative. So, the sign of this is +3. This slope is negative. And now take his reciprocal. So remember, this is 3/1. So I write it as 1/3. Okay, let's try the next one. First, let's take care of the sign. He's +1/2. My perpendicular line will have to have a negative slope. And the reciprocal of 1/2 is 2. Our next example is -4/7. So we're going to change him to a positive, and the reciprocal is 7/4. Now, this last one is the tricky guy. But remember, a line with a 0 slope looks just like this, which is a horizontal line. So we already know to be perpendicular, he has to have a slope that is undefined, is what I hope you said. I'm just wondering if your parents, if you're ever watching these videos and parents walk by and you're like talking to your computer. That'd be kind of funny. I'd like to get that email. Alrighty, so you ready? Let's try an example. Alright, example 1. Write an equation for each line in slope-intercept formula. Remember, slope-intercept formula is y = mx plus p. Okay? Alright, so number 1, we want it to pass through negative 2, 5 and parallel to 3x minus 2y plus 1 equal to 0. Oops, forgot the 1 there. Alright, so passing through negative 2, 5 and parallel to 3x minus 2y plus 1. Alright, so the first thing we need is we know we have a point and we need a slope, right? So we know we're going to start off with the same place we've been starting off with. The y minus y1 equals m times x minus x1. So remember your general form. Go to your point and say, well, I know his x sub 1 is negative 2 and his y sub 1 is 5. What's missing is slope. So I need slope. Well, I have an equation of a line, correct? I believe since I have his equation, I should be able to find the slope. So let's talk about how we're going to find the slope of this line. So I have 3x minus 2y plus 1 equals 0. Okay, and I'm going to kind of just do a little squiggle down my page so you know I'm really working two different problems here that will come back into one. So if I could get what by itself, okay, good. If I could get y by itself, I can find his slope. So let's go ahead and do some manipulating. First thing, I'm going to subtract 1. And again, I'm going to go ahead and show you all the steps. Feel free, though. I know a lot of you are to a point where you don't need to, but I'd like to go ahead in the notes and show you the steps. Okay? Now I need to move the 3x over, so I subtract 3x from both sides. So now I get negative 2y equals negative 3x minus 1. And my last step is to get rid of this 2. So I'm going to divide everybody by 2. Or negative 2, excuse me. So I get y is equal to 3 halves x plus 1 half. Now, what's important in that equation? The most important thing is right here. For this particular problem is I need the slope. Because what do I know about the line parallel to this line? They have the same slope. So I'm going to put that 3 halves here. And now I'm ready to do exactly what you did last night. So my recommendation to you now is be brave, pause the video, and then let's see how you did with your answer. For those of you who are still with me, I went ahead and rewrote this double negative as a positive, and now I'm ready to distribute. So I get 3 halves x plus 3, and then I'm going to go ahead and add 5 to each side, and I am done. Y equals 3 halves x plus 8 as my final answer. Alrighty. You ready to try a second one? Alright, let's see how you do. Let's do a perpendicular. I want it to pass through, so passing through negative 2, negative 6, and perpendicular to x plus 3y equals 12. Okay, so again, I have a point. I know I'm going to eventually have a slope. I'm going to use y minus y1 equals m times x minus x1. Okay? Alright, so here we go. Y minus stays, x minus stays. So let's fill in. What's x sub 1? Negative 2, and y sub 1 is negative 6. Now I need to find my slope. It's this equation here that's going to lead me to my slope. Okay, so I have x plus 3y equals 12. Your job is to get y all by himself. So let's subtract your x. and I get 3y equals negative x plus 12. And now to get rid of that coefficient, I'm going to divide everybody by 3. And I get y is equal to negative 1/3 x plus 4. So what's important here is, again, the slope. But this time I'm dealing with a perpendicular line. So when I come over here for his slope, I am going to change the sign and do the reciprocal. So I get positive 3. And now I'm just ready to go ahead and clean this up. Okay, so I get y plus 6 is equal to 3 times x plus 2. Now distribute, you're almost done. And I subtract 6. They go away. I get y is equal to 3x. Alrighty? Okay, let's talk. The last thing I want to do is spend just a few minutes talking about how to find rate of change for a linear function. Okay? So remember that it's going to be rate of change, so we're going to talk about average rate of change. Which is the change in y over the change in x, which is going to look like f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Alright, it looks super intimidating. I get it. Okay, so take a deep breath. It's not as bad as you think. Let's try one. Alright, example 2, last example of the day. Find the average rate of change of f of x equals x cubed from, we're going to do x sub 1 is equal to 1 to x sub 2 is equal to 2. Alright, here we go. I'm going to come over here to the side for just a minute. I already know my formula. So I'm going to go ahead and fill in my denominator. X sub 2 is 2, x sub 1 is 1. Okay, so the denominator is easy schmeezy. Now to get the numerator, I like to come over here to the side. So I know that f of x is equal to x cubed this time around. So I want f of x sub 2. I want to know what that's equal to. Well, what is x sub 2? I'm going to turn on the light just in case. I'm not sure. This video seems like it's pretty dark to me. So maybe that helps. You guys will, well, I don't know. It can't seem to figure itself out right now. Okay, I guess we're just going to deal with darkness. Alrighty, so here we go. X sub 2 is 2. So really I'm doing f of 2. Well, didn't you learn the other night that that just means plug 2 in for x and then do the math? So I get 8. Ta-da! There's my first number. Minus. Now what do? I come over here and I find f of x sub 1. Well, what's x sub 1? X sub 1 is 1. So I want to do f of 1, which is 1 cubed or 1. And now I just simplify. 7 over 1, which is 7. And that's my average rate of change. Alright? Okay, last one. Let's say I want x sub 1 is at negative 2 to x sub 2 is at 0. Okay, again, I'm going to go ahead and take care of the denominator first. So my denominator is x sub 2 minus x sub 1. Okay? Alright, let's scooch over to the side. And we know our function again is x cubed. So let's do x sub 2. So really that's f of 0. 0 cubed is 0. Alright, let's do f of x sub 1. What's x sub 1? X sub 1 is negative 2. What's negative 2 cubed? negative 8. Bring that over here. Now let's clean it up. So I get 8 over 2, which is 4. Okay? Alright, so that finishes up the lesson tonight. I'm going to give you one extra difference quotient for you to practice tonight since the video was short, and I will see you guys tomorrow.